Alright, so in this video we're going to apply the work kinetic energy theorem and figure out the speed of this block, of this 10 kg block, as it slides down this surface with an initial velocity of 0 and the coefficient of friction between the block and the surface being 0.5. So as I said earlier, we'll use the work kinetic energy theorem, and in order to do that we need to find the work done by the forces that are acting on this block. Now if you look at the forces, the free body diagram, the forces that are acting on it are 98 joules, which is the weight of the block, the force of contact, Fn, that we're going to find, and the force of friction, which is mu k times Fn as it's sliding. Once again we choose our x and y axis like so, and what this does is, now because of this we'll have to break the weight of the object into components, and the component along the y is 98 cosine 37 and the component along the x is equal to 98 sine 37. Now this gives me the force of contact, as there are no other forces along the y direction. It's only Fn and 98 cosine 37, and they have to balance each other out. This gives me Fn equals 98 cosine 37, and this happens to be equal to 78.4 newtons. Now once we know Fn, I can find the force of friction, which happens to be 0.5 times 78.4, which is 39.2 newtons. Alright, so now we have Fn, we have k, we have the weight of the object. So let us find the work done by each of these forces. First we'll find the work done by gravity. So Wg is going to be equal to 98 multiplied by 10 multiplied by cosine. Now let's figure out the angle here. And a common mistake that people make is that they take the angle to be 37 degrees. However, that is not the correct answer. If you look at the picture here, 37 is the angle that the incline makes with the horizontal, but the angle that we are interested in is the angle between the force and the displacement, and that happens to be 53 degrees. So be careful when you're doing this. So it's 53, and that gives me 980 multiplied by cosine of 53. Cosine 53 is approximately 0.6, and this gives me 588 joules. So now we have the work done by gravity. Let us find the work done by the contact force. Now that happens to be easy. It is 78.4 times 10 times cosine of 90 degrees, and that is simply because of the reason that if you look at the free body diagram, contact force and displacement are perpendicular to each other in this situation. That gives us 0 joules as expected. And lastly, we'll find the work done by the force of friction, which happens to be the force of friction, 39.2 multiplied by 10 multiplied by cosine of 180 degrees. And once again, the reason being that the displacement is down the incline, mu k Fn is up the incline, and they make an angle of 180 degrees. Alright, so this gives us the work done by friction, which is negative 392 joules. We have all the works now, so we can find the net work done on the object, and that happens to be 588 plus 0 minus 392, which is nothing but 196 joules. We're now ready to apply the work kinetic energy theorem, which says that W net equals KEF minus KEI. We know that since the object started at rest, KEI is equal to 0. We know the net work now, which is 196, and this gives me KEF minus 0. And so this implies that the final kinetic energy is simply 196 joules. So from here on, finding the speed is very simple. I use 1/2 times 10 times Vf square equals 196, and this gives me Vf square equals 39.2, and which gives me Vf equals square root of 39.2 meters per second. So this is my speed. This is the speed with which the block reaches the bottom of the incline. Alright, so that's it for this problem. Simply simple application of the work kinetic energy theorem.